Welcome to the class after the second term examination. We will start the new chapter, that is sound. That is the third term portion. So chapter name is sound, and it is the seventh chapter I am teaching you. Seventh and first lecture in that chapter. So session 7, lecture 1. We have studied about sound in the previous classes also, in class 7 also we have learned about that, and certain things regarding sound like frequency, amplitude, propagation of sound, waves, or certain applications that speed of sound in the different mediums, and also some questions also which we must have done. We will revise a few of them, and also certain elaboration is there. Now see, what is sound basically? So, if you define that in the form of energy, sound is a form of energy. If you have remembered chapter 4, it is dedicated to energy only, energy interconversions. So, sound is form of energy. Now, this energy causes us a sensation of hearing. So this energy causes a sensation of hearing. Now, why sound produced? See, always there will be a vibration associated with the sound production. So, if you speak, or you are singing, or you are saying to someone, you can just feel this portion where I am touching right now. You can find some vibrations that are occurring through your fingers. So that means whatever is the production of sound, or whenever there is some talk about production of sound, there has to be something which is vibrating. If you remember certain things that you are doing in the class at the back, like taking a rubber band and then stretching it, and if you remember stretching the rubber band, then what happens there? There is some sound produced. Now, this production of sound is attributed to vibrations only. That means there has to be some vibrations if there is sound produced. So, sound is form of energy produces a sensation of hearing. So, this hearing sensation is produced when there is sound is involved. So, if there is a body which is vibrating, then there is production of sound is there. What next? Certain things or some submit you might have done. So always there is a vibration associated with the sound. Now, can sound travel in vacuum? No. So sound cannot travel in vacuum. If you remember one activity in class 7 where we had a bell jar, and in the bell jar we had kept a electric bell. So, and we had a vacuum pump also. There is an electric bell here, which you can, whose button you can press from outside, and there is a vacuum pump or evacuating pump, and this was seen from outside. Then once you press the bell here, you will find that there was sound produced. If there is nothing in the bell jar, then also air is there. That means this air can help the energy to propagate. That means which energy? Sound energy. Once there is a vacuum pump is operational, that means once you press the vacuum pump so that all the air inside this bell jar is sucked out, then what happens? And then you press the electric bells button, you cannot hear any sound. What does it mean? Once you have created vacuum, though sound might be produced, but it cannot be propagated. That's why I say sound cannot travel vacuum. That means sound requires a material medium to propagate. I will write that sound requires a material medium to propagate. So since a material medium is required, that means you can compare it with light, which is an electromagnetic wave, and light doesn't require a material medium. So light can travel even if there is no medium. You can correlate this with the sun's rays, which are coming from the sun to the atmosphere and in the external space where there is no air. So then also they are traveling there. Yes or no? So there they are traveling and they are reaching the earth. Unlike that, sound is not an electromagnetic wave, so it will require some material medium for its propagation. Now what? If sound requires a material medium, then can we say the speed of sound can also change depending on the type of medium? Certainly. How? So, depending on the type of medium, the sound can have different speeds. So, what type of medium you are going? You can have solid medium, then you can have a liquid medium, then there is a third medium called as gaseous medium. Through these mediums, the sound can propagate, but see in which of the mediums the sound will be highest? Solids. Lesser will be liquids and least in gases. Now see, solids, how we can attribute to the high speed of sound in the solids. This can be attributed to the particles of solid being close together by the strong intermolecular forces of attraction. And what happens then? It happens that the particles can readily transfer it. The speed will be faster because molecules are closer together. Once they are close enough, they can transfer the energy which is carried by the sound waves. So speed of sound is highest in the solids, lesser in liquids and least in the gases. Okay. Now when a body vibrates, the particles of medium also start vibrating, and the kinetic energy of particles is into potential energy, and potential into kinetic energy of vibrations. So whatever particles are there, their kinetic energy is to potential energy, and potential is to kinetic energy. That interconnection keeps on taking place. Now, let us learn something about waves. What is waves? This is introduction to chapter only. Sound travels in form of waves. That means whenever there is sound is there, this will create some periodic disturbances. Periodic means something that is repeating after a certain interval. Periodic disturbances. Now, these periodic disturbances will be traveling, and whenever a sound is produced near the medium, there is periodic disturbance that is created. Now, these periodic disturbances will propagate, and this travels. So, this disturbance will travel in the form of waves. In form of waves. Got it? Then, and see, particles are moving in the form of waves. Where I explain in more details, you will learn about this. One more thing is there, this is called the tuning fork. You know, U-shaped structure is there, and a handle is there. Well, this tuning fork is a metallic structure. It is basically used to some of the experiments to tuning fork. So in tuning fork, we are having a U-shape. Two arms are there and one handle is there. Well, this handle is held in the hand, and when this through the handle you are using this arms and you are striking them against a rubber pad, then it will see that the vibrating, these arms will be in motion. They will vibrate, and if you keep your ear close to the arms here, you will find some sort of sound. So this is called a vibrating tuning fork. This basically proves that sound is always associated with some vibrations and periodic disturbances, and sound travels in the form of waves only. Then let us learn about some common terms. Some common terms used in sound. First term that you learn about is vibration. What is vibration? See, whenever you are having to and fro motion, that means a particle is there, it starts from its original position and comes back to its original position. It is called as one vibration. That means what? If you correlate to the simple pendulum that I had taught in the lesson 4 of energy, simple pendulum also had a bob that was moving from its one mean position, then extreme position, and then back to its again extreme position. So from the initial point, if it comes back to the same initial point, to and fro, it's called as one vibration. So and who's vibrating here? The particles of medium. So let me tell you about vibration. Basically, it is what? To and fro motion of the particles of the. Here they are telling in terms of the tuning fork. So for tuning fork, it's called as one vibration. And this tuning fork, we call it the prongs. This particular term we use as prongs. So to and fro motion, to and fro motion of the prongs of a tuning fork, to and fro motion of the prongs of tuning fork. Now see, when the prongs are vibrating, this is the actual prong, and when it is seen vibrating, you will see it like this. I have drawn the dotted lines, but there will be one position through which the prong will pass, and that is called as the mean position. If you correlate to the simple pendulum, there was one position in which or through which the pendulum was passing. It was called as what? The mean position. So that mean position the pendulum is passing. That's called the mean position, and others are called as the extreme position. So to and fro motion of the prongs of a turning fork about its mean position, about its mean position, about its mean position is called one vibration. Okay, that means the prongs are vibrating to and fro about their mean position, and that one to and fro motion of the means one vibration will be can be attributed to what? So it can be in reference to and fro motion of the prong. So these definitions are given in terms of the tuning fork only. So to and fro motion of the prongs about the mean position is called as one vibration. One vibration is to and fro. Okay, we'll learn more about the definitions like amplitude and frequency, then time period, then pitch, loudness. Okay, so all these things you'll be learning in the coming classes.